So we're just going to work on a couple of two-step problems. There's also going to be an ed puzzle where I go over this, but watching me work a couple of these in the classroom and at home would probably be a big help. Now, when I say two-step, what I mean is, let's start out, we're going to just talk about salt. NaCl. Okay, make sure I'm still on the screen there. Just barely. All right, there we go. We're going to talk about salt. Salt, we know salt has a molar mass of 58 grams. That's 23 plus 35, right? Right? But what if I was asking you a question? What if I had some salt on a scale and I weighed it? All right? So I've got a little scale here. And I put the salt on the scale. This little dots here represent salt. And let's say I have 99 grams of salt. And I want to know how many compounds, how many actual little NaCl's there are stuck together. Does that make sense? Then I would have to do a two-step problem. I'm going to go from mass, then I'll convert it to the number of moles, and then I'll go all the way to how many actual compounds are on the scale. And it's super easy, all right? There is a V-shaped equation that will work every one of these two-step problems, every time, without exception. Okay, and I haven't always taught it like this, but I've decided that this is the best way to do it. Here is the V-shaped equation. The first half of it, or part of it, will look familiar. The number you're given, okay, you want to copy this down. The number you're given over 1 times 1 over the proper number. Okay, now we did this yesterday. This will give you the number of moles. But we're going to keep going in this problem. We're going to keep going. The number given times 1 over the proper number. If we stopped right here, that would give us the number of moles. Times the proper number that you're asked for over 1. This needs to be given here, I guess, would be a better way to put it. Equals your answer. Now, when I say this is a V-shaped equation, that's because you enter a number here, here, and here. Does that make sense? This is what I mean by the equation being V-shaped. And if you go ahead and write these numbers down, then you're going to be right. You're going to be right every time if you write those numbers down. Okay? All right, so assuming you have this copied, check it out. Let's look at this problem right here. I got onto a scale and I weighed some salt. It weighed 99 grams. That's the number I was given. Right? Right? Everybody with me? In the back, you with me? With me? So the number I'm given, I'm sure you're doing something, honey. I'm just trying to get you to look up here, right? I'm given 99 grams times 1 over the proper number. Now the proper number here has to be the same units as the given number. Does that make sense? So these two always have to be the same unit. The proper number in grams for NaCl is 58, correct? Correct? So we're going to put 58 grams right here. And now, again, it's times the proper number asked over 1. What are we asked for? We're asked for how many compounds of salt are on the scale. So, what's the proper number for the number of compounds? What's the proper number? What's the units for compounds? 1 mole of compounds or atoms or molecules is what large number? Yes, people at home, you can't hear it, but they're all yelling the answer out. And they're nodding very affirmatively that they know exactly what I'm talking about. Yes, 6.02 times 10 to the 23rd is the proper number for compounds, molecules, or atoms. That's it. See how we entered the numbers in a V shape? See how the given number and this number are both the same units? You can't get a problem wrong if you do this, unless you hit a wrong button on your calculator. Right? So if you want to do this on a calculator, first, you need to write this down. All right? You need to be able to write this down. If you don't write this down, you're quadrupling your chances of missing it. Okay? If this was a regular year, you in the classroom, you would have to, if you didn't write these numbers down, I would count it wrong. Okay? You got to write it down. But let's do this. I'm going to say 99. Everybody got your calculator? 99. Then obviously, since this number is down here, what am I going to hit? Divided by 58. And now the next number is up here, so I'm going to say times 6.02 EE 23 equals. There will be 1.0 times 10 to the 24th compounds of salt on that scale. If there was 99 grams on the scale, there's 1.0 times 10 to the 24th compounds of salt. Yes? Oh, is that one busted up? Okay. All right, kids at home, we're going to do one more. So stick around for this one more. We just had a calculator emergency. Thank you. All right, let's do this one. Let's do a problem like this, except we're going to do one given the numbers differently. What if I'm going to use the same equation, okay? All right. This is the number given times 1 over the proper number. And these two have to be the same units, times the proper number of what you're asked for. All right? Here we go. What if we had some crazy microscope and we can look in on a sheet of aluminum foil? All right? So we have some aluminum. All right? And this is a crazy scenario. And then we zoom in on this area of the aluminum, and somehow we count the number of atoms of aluminum that are there, okay? And we count that there are 1.77 times 10 to the 25th atoms of aluminum in this space. Okay? Then we could say, well, if I cut this out with scissors, how much would that area weigh? What would the mass in grams? So, in other words, the question is, what is the mass in grams of 1.77 times 10 to the 25th atoms of aluminum? Okay? So we can really simply do this problem. The number we are given is 1.77 times 10 to the 25th atoms. All right? What is the proper number for atoms, everybody? 6.02 times 10 to the 23rd. We have to make sure that these first two numbers look the same. right? You can't put grams here because you're done. These two numbers have to be similar units, right? And then now it says times the proper number we're asked for. So we're asked for how many grams are there. So what's the proper number for aluminum in grams? 27. You just look that up on the periodic table. At the bottom of the aluminum card, it says 26.9, but we're just going to call it 27. And then there's your answer. Let's try it real quick. Did that calculator work? The one I got you? Okay, let's try it real quick. Everybody at home. 1.77 times 10 to the 25th atoms of aluminum would weigh how much? Here we go. 1.77. Hit the EE button and then put 25. Then we're going to say divided by 6.02, EE button, 23. Now we're going to say times 27 equals. It would weigh 794 grams. You would have 794 grams of aluminum. That would be a big old chunk of aluminum. That would be like that much the end of a softball bat. Does that make sense? That's about what it would be. The end of the softball bat about that long. That's how much aluminum would be in about 794 grams. Okay, so do you see, I'm going to give you a worksheet with this, but do you guys see why I'm calling this a V-shaped equation? Right? It's a V-shaped equation, and these first two numbers have to be the same units, and these are the given units, and this last number is what you're being asked for, the units you're being asked for. If you do this V-shaped equation, you will not get it wrong unless you just go clumsy-thumbsy on the calculator.